The atmosphere is also full of water molecules. Water molecules combine one atom of oxygen and two atoms of hydrogen. When water vapor condenses around tiny dust particles into liquid water, clouds form. The mechanical layers of the Earth. The layers of the Earth can be defined either by their composition or their mechanical properties. Compositionally, oceanic crust is made up of basalt, and continental crust is mostly granite. These rocks float on the denser silicate rocks found in the mantle below the crust. Iron and nickel make up both the inner and outer cores. When the layers of the Earth are defined by their mechanical properties, scientists analyze how the parts of the Earth move. The outermost layer of the Earth is the lithosphere. The lithosphere is made up of the crust and the transition between the crust and the mantle called the Moho discontinuity. Both the crust and the Moho discontinuity are solids. Around 12 tectonic plates come together to form the lithosphere. The lithosphere is between 50 and 140 kilometers thick. Continental crust is thicker than oceanic crust, so the thickness of the lithosphere varies. Within the mantle, beneath the lithosphere, lies the asthenosphere. The asthenosphere is solid but soft, like silly putty. The silicate rocks flow at about the same rate your fingernails grow. Convection currents within the asthenosphere send hot magma up through the volcanic vents and spreading centers in the middle of the ocean to form new rocks on the surface of the Earth. Colder rocks fall to the transition zone between the asthenosphere and the mesosphere. The asthenosphere is about 180 kilometers thick. The mesosphere stretches from 350 to 2,900 kilometers below the surface of the Earth. It is the thickest part of the mantle. Inside the mesosphere, the silicate rocks flow even more slowly than the rocks of the asthenosphere. The mesosphere rests on the outer core, which reaches from 2,900 to 5,150 kilometers below the Earth's surface. The outer core makes up about 30% of the Earth's mass. The mantle makes up about 67%, the crust 1%, and the inner core nearly 2%. The outer core is the only liquid layer within the Earth. Hot liquid iron and nickel swirl around the outer core as the Earth rotates on its axis. The spinning metals create Earth's magnetic field. The magnetic field surrounds Earth and reaches thousands of kilometers into space. It protects Earth by deflecting solar winds carrying charged particles that could destroy our ozone layer and expose us to harmful radiation from the sun. Inside the outer core lies the inner core, which is around 1,200 kilometers thick. Like the outer core, the inner core is made up of iron and nickel. However, even though the temperature within the inner core is the highest on Earth, the iron and nickel are solid because of the intense pressure at the center of the planet. The temperature within the inner core is a scorching 7,000 degrees Celsius, hotter than the surface of the sun. The heat in the inner core comes from the residual heat from the formation of the planet, the gravitational forces from the moon and sun, and the radioactive decay of atoms in the inner part of the Earth. We didn't know the center of the Earth was solid until 1936, when Ing Lehman, a mathematician and seismologist, studied data on the earthquake waves from around the world and realized the center of the Earth must be solid. In fact, because scientists can't visit the layers within the Earth, studying earthquake waves is a primary tool they use for studying the mechanical and compositional layers of the Earth.